Welcome to the Kick Sugar Coach podcast. Join me each week as I interview experts who will share the science of sugar, sugar addiction, and different approaches to recovery. We hope to empower you with the information and inspiration, insights, and strategies you need to break up with sugar and fall in love with healthy whole foods so you can prevent and reverse chronic disease, lose weight, boost your mood and energy. Feel free to go to my website for details on my coaching programs and to access free resources, kicksugarcoach.com. I have with me today Dr. Lewis Cantley, who has a PhD in biophysical chemistry. He's primarily and fundamentally a chemist and has been working in this space for decades. And 20 years ago, he stumbled on an enzyme that I can't begin to talk about the complexities of it, but basically it has a direct impact on how cells grow, and it is implicated in cancer. And what Dr. Cantley also discovered is that high glucose levels, high insulin levels, sugar, with that spike, both of those can switch on or activate this enzyme that can lead eventually to cancer. So he's here to share his passion for the topic of cautioning the world about our runaway consumption of refined carbohydrates, sugar, and also about things that we can do to protect ourselves from the damages that happen when we have high blood sugars and high insulin levels. So welcome, Dr. Cantley.
Well, thank you. It's a pleasure to get to talk to you.
And I should just add as well that Dr. Cantley, in the course of his research, he's actually had millions of dollars of funding because he keeps coming up with these little breakthroughs in these pathways. He's like right in the minutia level. And he has a variety of biotech companies that have been working to try and figure out how we can, create interventions to try and reverse or prevent the catastrophic rise in chronic diseases that we see today. So Dr. Cantley, I recall you sharing a story years ago when you were on my summit about how you had a personal epiphany about sugar and stopped eating sugar and drinking pop. That was like when you were young, wasn't it?
That's correct. I was only probably 20, 22 years old or so. And I noticed that I was gaining weight because I've been very thin all my life, even through high school. But I began putting on quite a bit of weight. And I realized it was because I was eating so much sugar, or at least it correlated with my increased consumption of sugar, because I didn't eat much sugar growing up. But sugar was starting to be added to every food by the time I was in my 20s. It was hard to find a food that didn't have sugar added. Even if you bought chicken, they would put sugar in the pastry, the coating of the chicken to make it taste sweeter. So people were getting sugar from all sorts of sources that never had occurred before. This was in part because sugar became very cheap with the invention of high fructose corn syrup. That was much cheaper to make than sucrose, normal table sugar. And it started being added to all foods that we ate. So we're getting sugar in our diet and not even knowing that we're eating sugar. So that's when I realized that I needed to cut down on sugar. So I quit eating all of these processed foods, eliminating eating anything that was a processed food, going back to just natural foods. And my weight came back to normal again. So that's what really inspired me.
Wow. So
at that time, I didn't really know how this all worked. I didn't know why sugar was causing an increase in obesity more so than other foods that you ate. If you just count calories, you'll get more calories per gram by eating fat than eating sugar. But if you eat fat, you don't get fat. If you eat sugar, you do get fat. And that's the surprising thing.
Why
we understand that better now.
Yeah. Why does sugar make us fat and fat doesn't?
Because sugar raises insulin levels. So we know insulin is, the miracle hormone that keeps our glucose in check. People who get diabetes, it gets diabetes because they're not making enough insulin to keep the glucose down. So we think of insulin as, our friend. It is what helps keep our glucose low enough. But what my lab discovered many years ago is that insulin activates an enzyme called Pi3K, or phospholinositide 3 kinase is what those letters stand for, Pi3K. And that enzyme is one of the most mutated genes in cancer. And what those mutations do is they make that enzyme respond better to insulin. You still need insulin. So to me, that suddenly produced the striking, shocking conclusion that these elevated levels of insulin that most people in America have due to what they eat is putting it at a much higher risk of getting cancers, or if they already have cancer, much higher risk of dying of that cancer. So that connection had not been made before, that diabetes and cancers are really two aspects of the same problem that has to do with insulin signaling.
And I do recall hearing that, was it Warburg that had discovered that cancer loves sugar? How does that marry up with what you discovered with the PIK3 enzyme?
Or Pi3K, yeah.
Sorry.
So, well, it is the Warburg effect is completely explained by this. At the time Warburg made that observation in the 1920s, insulin wasn't even known to exist. Nobody knew what insulin was. But what our work showed was that it's the elevation of insulin that activates Pi3K, and activation of Pi3K is one of the most frequent events that happens in cancer. You either get mutations, gain of function mutations in that gene, the gene that encodes Pi3K, or you lose a tumor suppressor gene called P10, PTEN, that actually breaks down the lipid that Pi3K generates. So either way, you have gain of function mutations in Pi3K, or you lose P10, you get the same consequence of the lipid product of Pi3 kinase being elevated. And that drives glucose into muscle and fat tissues. Normally, that's what it's designed to do. But it also drives glucose into the cancer cell, because the cancer cell has those mutations. And so it will take up glucose better than any other tissue in your body. And that's what Otto Warburg observed, that these tumors were taking up glucose at a much higher rate. And we use that in the clinic today at something called FDG PET, which probably everyone has had some relative, not themselves, had a PET scan. And what they do is use a radioactive form of glucose and just monitor where it goes. And if you have a tumor, it's taking up glucose better than any other tissue in your body. And so it lights up like a Christmas tree with FDG PET. That's because it's taking up glucose. And that's due to these mutations in Pi3K and P10. Usually it could be other genes too.
Your genes. And what's happening is we've got all these processed junk foods and the sugars that are driving up blood sugar levels, driving up insulin levels. And the high insulin is what creates these mutations. Is that what activates that? Or how do these mutations happen?
The mutations happen by chance. Any gene in your body can, with age, all of our genes begin to mutate. And most of those mutations are loss of function mutations. Fortunately, we have 2 copies of every gene, so you can get a mutation on one and the other still works, so you're okay. But these mutations in Pi3K are at specific sites that cause gain of function. So if a single cell somewhere in your body picks up a mutation in Pi3K, that cell will take up glucose better and will grow faster than the surrounding cells that didn't pick up that mutation. And if a couple of other mutations then occur as those cells begin to grow faster, there can be additional mutations, and that can ultimately result in a cancer. Now, if you only get the Pi3K mutation, but not others, you just get an overgrowth. Those cells grow faster, but they're not truly cancerous. You need additional mutations to get a true cancer to occur.
I see. And those mutations are not connected to how we're caring for our bodies, our self-care, our food choices, etc.
Well, it's almost impossible to live a life where you never get exposed to something that will cause a mutation in some gene. So, sunlight will cause mutations in your skin, and these can ultimately result in the types of events that I just described, and those result in melanomas. So that's how a melanoma occurs. And those are sometimes mutations in the Pi3K, P10 pathway. But foods that we eat can cause mutations. Aldehydes, alcohol can result in reduction of aldehydes, which can cause mutations, particularly in the liver. So it's, ultimately, if you live long enough, you're going to get a mutation somewhere in every organ, every tissue in your body.
Right. Some of that's just natural, but it sounds like potentially we're escalating through epigenetics. We're escalating the mutations and the risk of having these mutations morph into cancer or other sort of diseases.
That's correct. So one cancer that's in particularly very highly related to sugar consumption, and in fact, it's related for a reason not because of insulin, but because of something else, is colorectal cancer. So we know, in fact, over the last 50 years, colorectal cancer is appearing in younger and younger adults. It used to be a disease that only occurred in people over 60 or 70 or so. But, over the last 30, 40 years, we're seeing this in people who are 25 to 35 years old. And we did a study of colorectal cancer a few years ago. I think it was about 10 years ago, in which we were using mouse models where we engineered in the same mutations in the mouse colon that we see occurring spontaneously in humans. And then we asked, what do we get these cancers, and are they affected by diet? So we tried a variety of diets. In the colon, of course, the food that you eat goes directly into the colon. So, ultimately, part of it makes it all the way to the colon, certainly through the small intestine as it gets absorbed. And so one of the questions we were asking is the food on its way through your lumen of your body, the tissue, the intestine, colon, can it affect a tumor that's growing there already, a microtumor? Can it be influenced by the sugar that's on the outside? And the answer is yes, that as the sugar goes through the intestine and to the colon, the cancer cells will absorb it directly rather than the sugar having to get into the bloodstream first and then make its way into the tumor. It can make its way directly from the lumen of the intestine straight into the tumor, because the tumor has transporters that take up fructose and glucose. The two aspects of sucrose is made up of 50-50 fructose and glucose. And those get broken down in the intestine, and they can get absorbed directly into the tumor from the colon. So, but for this to happen, the sugar has to make it all the way to the colon. And so this will happen if you have sugary drinks. So if you have sugar that's cooked into meat or slowly digested carbohydrates, it's unlikely to be high concentration enough or available enough to get directly into the tumor or the microtumors that are growing in the colon. But if you eat sugary drinks, drink sugary drinks, they will make it straight into the tissue, make it straight to these small polyps, we call them, and make them suddenly turn into a tumor. And so this explains why we now see people in their 20s and 30s coming down with colorectal cancers, when it used to be nobody had colorectal cancers until 50s or 60s. So that's a cautionary tale. And this is a problem where it's not correlating with insulin or obesity. So the young people who are coming down with these colon cancers are many times they're athletes. So they do a marathon run or extreme exercise. Then they come back and they drink a sugary drink to try to get their energy back. So they're drinking very large volumes of sugary drinks to recover. And that high level of sugar is causing these tumors to appear in their colon. So it's something that we really have to warn young people about. I mean, warn everyone about, and in particular, young people who think that they can take these very high volumes of sugary drinks after they do their exercise, and that it's not going to be a problem. It's not going to be a problem for them gaining weight because they exercise so much, but it's going to be a problem for them coming down with colorectal cancer.
Is that ever the truth? My daughter used to play competitive volleyball, and it's like all the sports teams, all the coaches, everybody's been brainwashed that Gatorade is the choice, the drink of choice for athletes. It's not pop. I kept saying it's pop. It's the equivalent of pop. Don't drink it. Let's make our own, sort of electrolyte drinks. And they would have no part of it. Like everybody was brainwashed that all of these sports drinks are healthy. They're good for athletes.
Yeah, and they add a lot of sugar to it because, in fact, if you didn't add sugar to it, it wouldn't be very easy to drink. It wouldn't taste very good.
Doesn't taste very good, all those electrolytes. Yeah, a bit
salty.
salty.
They, of course, are arguing that adding the sugar also gives you more sugar to exercise.
Right.
Your body needs a certain amount of sugar.
Right.
But it's very dangerous for the colon.
Very dangerous for everybody. But yeah, all these young kids that are trying to be healthy and happy, right? And we're just pouring stuff into their systems that I don't even know where to begin to try and hold these corporations accountable for that. What about sugar and diabetes? Has your research sort of shed any light on that link?
Yes. So we're talking about type 2 diabetes, where you get elevated glucose due to the inability for particularly muscle, but fat cells, muscle, and other tissues to respond to insulin. And this is a failure to be able to activate the enzyme that my lab discovered, Pi3 kinase. So it's called insulin resistance. And that results in elevated glucose in the bloodstream because the tissue will not respond well to insulin. Now, the consequence is your pancreas will make a lot more insulin because it senses that glucose levels are still high, even though it's already released some insulin. So it will continue to release more and more insulin. So the problem there is that not only do you have high circulating glucose, but you have very high levels of circulating insulin. And from what I told you about the fact that mutations in cancer allow them to respond to insulin better, and if you're having this continual high level of insulin to the insulin resistance, it's going to increase your risk of getting a variety of cancers. And we know that's true.
Mm-hmm, mm-hmm. What are the other dangers of high insulin?
Well, that's the main issue. It's, most endocrinologists consider, insulin like the miracle drug. When insulin was discovered back in the late 1920s, and suddenly you could treat type 1 diabetics who don't make insulin. You can give them insulin and suddenly they thrive, they grow. Now, even then, when that discovery was made, it was very obvious that what insulin does is make your tissues grow, because the children who had type 1 diabetes were very small. They would weigh like 1/2 what a normal child their size would weigh. And that's how they were originally diagnosed. They were confirmed by the evidence that there was glucose in the urine, which could be picked up by a variety of approaches. And so that it was, the disease was actually discovered before insulin was discovered. And we now know how it works. But it's so giving insulin people who can't make it rescues those individuals, allows them to live a normal life. But for type 2, that's for type 1 diabetics that can't make insulin at all. But for type 2 diabetics, it's not that they can't make insulin, it's that they don't respond to it, and therefore they have to take even more insulin. And that's the danger. If you're taking even more levels, higher insulin than normal, as opposed to a type 1 diabetic taking insulin, a type 2 is just taking a much more higher level of insulin. And that's a concern, given what I said about insulin activating, stimulating the growth of any tissue that has a mutation in Pi3 kinase.
Mm-hmm, mm-hmm. And I know from my father, he was never flagged as diabetic. And I don't think they even screened for pre-diabetes back then, but his blood sugars were always fine. But he had all the signs and symptoms of diabetes. He actually had a double amputation. He had neuropathy, all kinds of 3 heart attacks, right? But he was never a diabetic. And my understanding now is that there are people with strong pancreases that continue to pump out a lot of high insulin. It is bringing the blood sugars down to some extent. So he doesn't show up on the radar as being metabolically problematic, but he has really high circulating insulin levels. And back then they didn't know that was dangerous to tissues of the body.
Yeah, the one way to monitor that over the long period of time, because of course your insulin levels go up and down with your meal. So if you measure insulin levels right after eating breakfast, you're going to get a very different level than if you measure it right after you got out of bed without eating anything. And so the insulin level will be, like 20-fold different in those two scenarios. But there is a maturation peptide, it's called the C peptide, that is co-synthesized with insulin, that during the last step of insulin secretion, it gets clipped off and it ends up in the bloodstream as well. And it has a longer lifetime in the bloodstream than insulin. So endocrinologists will often measure C peptide rather than insulin because it's a better indicator of the long time level of insulin over the last 24 hours as opposed to what you ate in the last hour.
Mm. And isn't the C peptide also considered a measure of inflammation in the body?
I think if C peptide is high, that certainly means your body's making a huge amount of insulin. That could contribute to inflammation, but I'm not sure of that connection.
That link. Mm-hmm, mm-hmm. So one of the books that you had mentioned that you love, that you wanted to sort of talk a bit more about, was Peter Attia's book, Outlive. What in particular in that book do you feel is important for the public to know?
Well, I think that, when I first moved to Weill Cornell, I met Peter Attia. He sought me out because I think he had seen something I'd done on television on 60 Minutes. I'd done an interview on 60 Minutes. And so he was an endocrinologist, a cancer doctor, but he also was himself diagnosed with type 2 diabetes. And he was overweight in his mid-30s as a practicing physician. And then he realized that he was actually becoming very unhealthy himself at a young age, in his mid-30s. So he completely changed his diet and wanted to meet with me because, as I say, he'd seen my interview. And so we ended up becoming very good friends and periodically went out to dinner together. In some ways, he was curious as to what I would order at dinner, so that you can see what I'm eating to mimic what I was doing. But he's really a great guy. He sent me a copy of his book, And I haven't actually finished it yet. It's quite a long book, but I think it's a spectacular book. It seems to
Mm.
be really a lot of detail about, what you need to do to stay healthy.
Yes, and he touches on the whole mental health and the stress, and it's not just about what we eat. That's essential. It's sufficient, but not always necessary to turn things around that were complex, and all these pieces, exercise and our mental health and all those pieces have to come together.
Yeah.
What else do you want the public to know and understand about the danger, the threat of sugar consumption?
Yeah, I think that yeah, I mean, I touched on the issue in the colon, the fact that you can get colorectal cancers from consuming sugar, particularly sugary drinks, that even though you're completely not obese, you're plenty of exercise. I think this is a point that I really want to get across to young people, that they, just because they haven't gained weight doesn't mean that sugar they're drinking is not causing a potential problem. And since rarely do young people have colonoscopies, they're not recommended until you're like my age, or at least in your 50s. And so we're now finding a lot of young people coming down with colorectal cancer that is shocking the medical community, that, why they've never had a colonoscopy because they aren't old enough to have one. Do we need to start asking people to have colonoscopies earlier in their life? I think just trying to scare them away from drinking sugary drinks is the better solution than to try to cure it after it's already happened. So prevention, of course, is always the best.
Absolutely. And do you take a hard line yourself with your own body, no sugar, or do you make exceptions?
I actually do not have anything with sugar added to it. And that means, obviously, my wife always loved to make desserts, but when she saw me converting to no sugar, it really changed her cooking focus from making dessert the main punchline of the meal to focusing more on healthy meals without desserts. If I do have a dessert, it will be something like an apple.
Piece of fruit.
But I don't think I've eaten ice cream in 40 years.
Incredible.
And
You are not the norm, Dr. Cantley. Like, most of us think, oh, I should probably break up with sugar. I should probably just be a whole food man or a whole food woman. But most of us struggle, like we're on and off, and we're like, oh, it's just a bite, oh, it's my birthday, and or the pressure, there's nothing else to eat, right? We just don't stick with it quite like you did. That must have been quite the revelation for you to have it stick in your brain so well.
Well, as I say, if you've actually done the research, and including not only at the biochemical level, but even at the whole animal level with mouse models, where we feed them various diets and then look at cancer growth. But when we put mice on a high sugar diet, in the context of already having a mutation that predisposes to get some cancers, and you just see the cancer takes off like crazy with the sugar. Mice die much faster with combining a mutation, particularly a mutation in the Pi3K or P10 genes that my lab identified. If you have a pre-existing mutation, one of those, and take sugar, tumors take off like crazy.
Yeah, it's a bullet to the head. Wow. And what about if you don't have the P1K3 mutation?
Pi3K.
Sorry, PI.
It stands for phosphatidylinositol. P and the I is for the inositol part of it. So if you don't have those mutations, insulin can still stimulate the growth of the tumor. It's just that if you do have either a P10 or a PIK3CA mutation, then the insulin response is going to be even more dramatic. But even without those mutations, elevated insulin is not healthy.
Got it. And when they do that, I did my nutrition genome through, I think it was Nutrition Genome, and I don't recall if that was one of the genetic mutations SNPs that they tested for. Do you know if they're testing for that genetic mutation these days?
Well, if you had a mutation in PIK3CA or P10 that's germline, then it would you would have already been diagnosed with a cancer.
Oh.
By the time, in fact, you might have had something called a short syndrome, where you get hypergrowth of some tissue in your body.
I have had cancer. Yeah.
So
Interesting. Yeah.
but yeah, if it were germline, then that would mean every single tissue in your body has that mutation. So you would be guaranteed to get something happening.
Okay, so when they do the sequencing of our genes through like 23andMe or Nutrition Genome or whatever, they're testing at the DNA level as opposed to at the cell level.
You're testing at the DNA level. Of course, the DNA is coming from the cell, but it's coming from your cheek swab, right?
Mm-hmm.
Get sent to a cheek swab.
Yep.
So you could have done it from your toe. You could have clipped off a little bit of tissue from the tip of your toe or your arm or anywhere in your body, and you would still get the same germline mutation no matter where you take it from. So you're sequencing all the genes that are in every cell in your body. Now, all those genes aren't expressed in every tissue. Different tissues express different genes.
Mm-hmm.
But if you had an underlying mutation in that cheek swab, in the gene for Pi3K or P10, I will guarantee you would have had a series of cancers by now, or overgrowth syndromes.
Got it. And so the best, if someone has those mutations and are high risk for cancer, keep your glucose levels as low as possible, or like within the range, and your insulin levels low, and that significantly decreases the likelihood that you'll get cancer and the likelihood that you will die of cancer.
Yeah, I've met with a number of women who have children that have this disease. So they themselves nor their husband had the disease. So these are sporadic events that happen during development, and they would be not in every single cell in that embryo, but only in a few cells that or probably only one cell initially that picked up a mutation at some point in embryonic development. And then the tissue that emerges from that cell as the tissue develops, as the child develops, will now have that effect. So that's the only tissue that's going to have the cancer-like syndrome. And it gets manifest at this early stage in the child by an overgrowth event. And these are often diagnosed right at birth, that you see like an area of the arm is just much bigger than the rest of the body, or a leg is much bigger.
Mm-hmm.
And a few years ago, they started doing biopsies of these overgrowth syndromes and sequencing them. And that's when they discovered they all had mutations in Pi3K.
Okay.
The same mutations you would see in cancer, but these aren't true cancers. They're just overgrowth syndromes.
Got it.
They can ultimately result in cancers, but at that stage, they're not a cancer.
Got it. Mm-hmm. So what you're saying is basically I gave up sugar because I was a young man and I didn't want to get more overweight. And then later in your labs, over 40 years of research, every time you study sugar, you're like, oh no, this stuff isn't good. And it's just kept you on the straight and narrow and the true.
Yeah, it's not a problem. I don't ever see it as a problem. If you can go for 6 weeks without eating sugar, you can break the addiction. It's like any other addiction. It's like heroin, or it's most people say I couldn't possibly go without eating dessert for a week. I couldn't do that for a week, much less for 6 weeks. But people I've talked to who've read my books and decided to do it, what they tell me is if they go 6 weeks, they can do it. If they cheat during that 6 weeks, they'll never be able to do it. But after 6 weeks, you don't care anymore. You don't crave the sweetness Getting past the craving is what's critical.
Right. Did your wife follow in your footsteps?
She's pretty much, she eats more than I do, but given that we rarely have dessert, given that it's boring for her to make a dessert and I don't eat it. She's, she still weighs about the same as when we got married.
Yeah. She's more or less is followed the whole food path. Yeah. It's amazing how people around us can be skeptical and look at from a distance and think, oh, that's too extreme. And I could never do that. But slowly, decade over decade, as they realize, hey, wait a minute. Every single year or decade, I seem to be, getting another pill or another ache or a problem. And, there's Lewis doing just fine. maybe I'll jump on this bandwagon.
Yeah, I'll guarantee taking all sugar out of your diet will make you healthier. You'll never regret it.
Right.
It'll take 6 weeks before you break the addiction.
Right. And they can, yes, awesome. And then you can fall in love with whole foods, and they're every bit as good once you've recalibrated your taste buds. Is there anything more you would like to add today that you would like the audience to know or understand about sugar and the harms of sugar?
No, I think we covered pretty much everything that I know.
Okay, awesome. And you mentioned your books. Is there a book that someone could get to read to learn more details about what you know?
I've not written a book myself. I think Peter Attia's book is really a good book to read because he's done much. He does a very broad look, not just at sugar. He's looking at everything that affects your longevity.
Yes.
How to live a healthy, long life.
Yes.
And so I haven't gotten all the way through it yet because it's a big book, but I wouldn't try to do a book better than that one.
Okay. Yes. Awesome.
And he's a medical doctor, so he has a very broad knowledge also of diseases. So.
It takes years in the front line working with people to kind of understand the biodiversity and all the pieces and the complexities of it all, for sure. I just wanted to add that Dr. Cantley is a chemist. He's a PhD scientist. He works in the labs. He works with biotech companies. He doesn't have to do this interview, right? There's nothing in this for Dr. Cantley except to be here to warn you about the harms of sugar and what he knows about sugar's tie and connection to cancer. So I hope you take it to heart. And I hope this was maybe the kick in the pants that you need to do what he's doing, which is not eat sugar. Thanks again for being here today.
Well, it was a pleasure to talk to you. Bye.
Thanks for tuning in this week. If you would like more interviews, more information, and more inspiration on how to break up with sugar, go to my YouTube channel, Kick Sugar Coach, or my website, kicksugarcoach.com. See you next week.